Good afternoon to my fellow classmates. I am DARWENDY BINTI, holder of metric F25A1574. Today, I am excited to present our agri-technology project entitled Calculus in Malaysia Biomedicine, optimizing the development of Musang King D197 durian. This project demonstrates how calculus can solve real-world problems in our natural agriculture industry through precise data analysis. The focus of my study is to examine how the integration of modern mathematics can advance the local agriculture sector, especially in helping farm improve crop yields through precise data analysis. The main issue faced by Malaysia durian farm is pinpointing to exact optimal to apply fertilizer. The biological weight growth of a durian does not follow a simple linear path. Instead, it follows a specific biological curve known as the sigmoid or logistic function relying on guesswork for fertilization lead to massive cost wastage. By utilizing this mathematical model, we target a yield increase of up to 40% through three main impact is nutritional precision, cost efficiency of NPK fertilizer, and guarantee consistent export quality. We model the cumulative weight of the durian using the logistic function. He L represent the carrying capacity of maximum weight, which is 2000 gram to kilogram. K is the growth of the factor, and T0 is the midpoint they set at the 65. The green curve, the graph visual how the fluid weight starts slow, surges drastically during the exponential phase and eventual plunges out at maturity. This path represents the heart of our project. This dual-axis graph simultaneously display the original function and its derivative. The solid green represent the physical cumulative weight of the fluid over time. Meanwhile, the dashed green line represent the first derivative ft, which signifies the instantaneous growth rate. Notice the red dot right in the middle. The absolute peak of the growth rate occurs precise on day 65, accelerating at speed of plus 40 gram per day when the fluid weight exactly 100 gram. This critical interaction of mathematical grow as the inflection point. Academical, we prove the extent of this inflection point using the second derivative setting s equal 0 right after day 65. The law of diminishing return begins. The fluid continues to gain weight, but the acceleration of the growth slowed down. The HTML diagnosis system we developed provides this rapid aerial explanation flash developed fast in real time. This backend algorithm allows agronomists to predict future fluid weight automatically without requiring farm to pluck or damage the fluid on the tree. Based on our analysis, growth incredible slow from day 0 to 60 after blooming. However, precisely on day 65, the system triggers a critical peak alert. This is the golden window. We farm must supply maximum NPK nutrient because the fruit cells are dividing at the fastest rate. When guided the mathematical precision, the results are extraordinary. The physical shape of the durian become perfectly round and the flesh develop the signature deep golden color and premium cream texture, the D197 clone. Before ending my presentation, I suggest a few future improvement to our HTML tool. Is integration real-time LOT by connecting the code or to actual soil sensor, developing a mobile-first interface for smartphone access directly in the field, adding AI simulation to predict extreme weather condition, providing bilingual support to expand market accessibility. To close my presentation, I would like to quote a saying. Calculus is the language of nature and it is the key to achieving the perfection of a Musang King D197 durian.
Okay. Hello everyone. My name is Auni from the SFH. Today I want to present my project Calculus in Animal Husbandry, Kedah Kelantan category. My project is about Kedah Kelantan category in Malaysia. This cattle grow very slowly, so I use calculus to find the growth rate using the first derivative f prime of t. I also find the point of inflation using the second derivative f double prime of t equal to 0. This point shows the maximum growth speed of the cattle. Why is this important for Malaysian farmers? First, it helps farmers know the exact best time to sell the cattle. Second, it helps farmers plan the food schedule, save costs, and avoid waste. Okay, this is my website simulator host on GitHub page. Users can choose different cattle types like purebred, KK, or Brahmas. I included bioscience factors like nutrition quality and heat stress. When we click the graph, the HTML code calculates four things in real time. First, age. Second, like weight. Third, growth rate. And lastly, average daily gain, ADG. So lastly, I can improve this HTML tool by adding an automated feed calculator. It will read the live weight data and automatically suggest the best food amount for the cattle. Okay, that's it all from me. Thank you.
Hi, everyone. My name is NURUL AFRINA. Today, I will present my GitHub page project, which focuses on a bioscience problem in poultry farming in Malaysia. The bioscience problem I choose is about feed cost management in broiler chicken production. Feed costs can reach 70% of the total expense, so farmers need to know the most effective time to harvest the chicken. If harvest too early, growth potential is waste, and if harvest too late, feed is based on slow growth. My weight page use mathematical modeling to analyze this problem. Important of studying this bioscience problem is to improve feed conversion efficiency (FCE), how effectively feed is turned into body weight by applying mathematics. Farmers can reduce feed waste. The second one, to increase profit margin and maintain animal welfare. This shows how biology and calculus can work together to solve a real agriculture challenge. Now, I will explain the each section on my web page and explain what is meant. This section, the bioscience problem. This section introduces the real issue, high cost in poultry farming, and it explains why mathematical modeling is needed. The second, the mathematical model plot here to show the Gomez function, which predict chicken growth. The formula calculates total weight and at a given day and it derivative show the daily growth rate. This help identify the peak growth period. And at the graph, the growth curve and daily velocity. This chart compares cumulative weight and daily growth rate. This green line show the total weight, while the blue line show growth velocity. It helps visual when growth is faster and when feed efficiently decline. At day 1, boarding pace slow growth. Day 23, near inflection point, fast growth. Day 28, still a pre-growth high metabolism. And at day 45, plateau stage, grow slow, harvest recommend. This cut connected to caucus result directly to farm management decision. Uh, one way to improve this HTML web page is to add responsive interactive chart. For example, user could adjust constant like and instantly see how the growth curve changes. This will make the web page more engaging and additional. In conclusion, thank you for listening. This project demonstrate how mathematics and bioscience can be combined to improve farming efficiency and sustain. By modeling growth with calculus, farmers can make smarter decisions and reduce costs. Thank you.
Good day, everyone. My name is Sagar Sugumaran, F25B1502 from SFA. And as a describer, I'm going to present my web application, Agromet Analytic, which is deployed live on GitHub. This platform bridges the gap between raw biological observation and mathematical modeling. It serves as SFA Agrotech Bioscience portal designed to optimize modern agriculture intervention through real-time mathematical telemetry. Over the new few minutes, I will guide you through the biological problem, its mathematical solution, and the web functionality. The specific bioscience problem this platform target is the inefficient distribution of nutrients during critical psychological growth phase of Marumanis mango, that is Infera indica in early Indonesia. In modern greenhouse managing automatic In modern smart greenhouse managing automatic irrigation cycle can be incredibly expensive and waste if done blindly. The fruit mesh follows a classic stack model growth curve. Without species modeling, agricultural technology cannot easily pinpoint the exact day the fruit hits the maximum daily weight gain, and critical window where psychological change demand highly optimized water and potassium inputs. Biologists address this by taking localized agrotech data and applying magnetic tracking to map this growth curve dynamically. Studying and modeling this biological growth phase is crucial for three major reasons. First, precious agrotechnologies. Instead of relying on guesswork, farmers can use empirical data to schedule precise automatic fertigation cycle, reducing fertilizer runoff and cutting operational cost. Second, economical maximization. The harmonized mango is premium, high-value signature fruit in Asia. Maximized fruit size to 450 gram potential direct impact export, quality and agriculture yields. Third, pest mitigation. Identify the exact inflection point in the fruit life cycle tells farmer exactly when the fruit is most vulnerable, enabling timely psychological intervention to protect the crops. So now I'm going to explain the web page. In point 1, the scenario data validation panel on the top left. We established our biological baseline. We have validated our parameter against official Malaysia standard. Utilize data from the Department of Agriculture, that is DOA, Malaysia and MOHD. This ensure our model anchored to the real world maximum mature fruit size of roughly 450 grams over 110-day time frame. The calculation formation engine. This is the formula. To the model mass, the system use logistic growth curve function where is our S total at 450 gram is our growth coefficient of 0.08 and represent our psychological inflection point at day 55. To find the rate of change, the system calculates the first derivative which yield the exogenous growth the rate in gram per day. Dynamic analytics in machine telemetry. So now the green line showing the aromatic mass and the yellow line is Historical growth rates. And the red line is local derivation, and the black color points indicate the current position. So in day 55, the interface flashed a green alert showing we have reached the maximum psychological peak. The derivation reached its global maximum here, showing the food mass is 225 grams and exogenous growth rate is 9 grams per day. So in the graph we can change and we can see the daily progress. The final point is advisor section. The website translates complex calculations to practical farming tasks. For day 55, it showed the grower that cell extension at its peaks, requiring high potassium and regulate osmotic pressure, and trigger a crucial instruction to immediately wrap a bag managed to prevent from fruit fly. To elevate this HTML application to produce great standard, my primary recommendation is to integrate of indicate mathematics typesetting library like text and Majax. Currently, while our core calculus formation render beautifully, our dynamic real-time telemetry panel outputs raw, unscratched latex strings directly into container text when the slides move, such as showing the raw and sys text. By importing a lightweight JavaScript mathematics engine via on CDN, we could dynamically interpret and variable value of from our slider, trace the latex formatting programmatically, and display beautiful typeset equation in the real-time card without slowing down the DOM rendering. That concludes my presentation, agronomy analytics, by pairing precious calculus with real-world agronomy workflow. This application show bioscience can be effectively digital. Thank you.
I just had to let you know you're